Hi everyone, this video is about sequences and series. Today we are going to be focusing on the topic of sequences. This video is for IB Math SL. We will be starting with defining some key vocabulary words. I'd like you to write these in your own notes, Cornell style, and if at any point I'm talking too fast or going through the slides too fast, you can freeze or pause the screen and then continue on at your own speed. The first vocabulary word is sequence, and a sequence is a list of numbers that are written in a specific order. So for example, A, B, and C, I have a list of numbers there, and these are all considered sequences. The next vocabulary word is a term, and a term describes the numbers that are in a sequence. So for example, if I look at example A, I have 1, 3, 5, 7, 9, 11. These are all terms. I could say that the first term is 1, the second term is 3, the third term is 5, the fourth term is 7, etc. And there are, let's see, 1, 2, 3, 4, 5, 6 terms listed in the sequence. Now, when we're looking at sequences, mathematicians are really only interested in sequences that have some sort of pattern or rule. And in situations where there is a pattern or rule, we can write them out using math language. In this class, we're going to be using the letter U sub n to define sequences and to describe sequences. And U sub n, this symbol together, denotes the value of the nth term of a sequence. So for example, what I mean is if I look at the first sequence A, the value of the first term is a 1, the value of the second term in this sequence is a 3, the value of the third term is a 5, and the value of the fourth term is a 7. I would write this mathematically as U sub 1. The value of the first term is a 1. The value of the second term is a 3. The value of the third term is a 5. And the value of the fourth term is a 7. And so that's how we would use mathematical language to describe the value of the terms in the sequence. Now, when we are looking at sequences and trying to find a pattern to it, we can look for patterns either using a recursive rule or a deductive rule. So really two ways. We're going to start by talking about a recursive rule. A recursive rule is when you look at a sequence and you're trying to link new terms to previous terms in the sequence. For example, if I give you the sequence 2, 6, 18, 54, and 162, I might try to look for a pattern and say, it looks like my next term is maybe 3 times my previous term. So let me double check. 6 is 3 times 2. And 18 is 3 times 6, and 54 is 3 times 18, and 162 is 3 times 154. So my next term is probably going to be 3 times 162. So here I've established a pattern using a recursive rule. I'm able to find the next rule based on a previous term in this, I'm able to find the next term, the value of the next term based on the previous term in the sequence. Now we would write this recursive rule using these symbols right here. Okay, and what this means is each term, the value of the term, is 3 times the previous term. I thought it would be helpful to include a table. So in this table, nth term means the first term, the second term, the third term, the fourth term, and the fifth term. And then the second row, I'm telling you the value of that term. So the first term is a 2, the second term is a 6, the third term is a 16, the fourth term is a 54, etc. So using this recursive rule, you could say that the value of the next term, so let's look at 18, the value of the next term, which would be 54, is equal to 3 times the value of that term, the previous term, 18. Okay, so let's say if n is 3, right, n is 3, u sub n is 18. And if I multiply u sub n, which is 18, times 3, I would get 54. And 54 is equal to 3 plus 1, 4. The fourth term is equal to 54. The second way of finding a rule for a sequence is a deductive rule. And the deductive rule links the value of the term to where it is in the sequence. So if I give you a sequence 1, 4, 9, 16, 25, looking at that, there doesn't really seem to be a pattern where I'm like 1 plus 3 is 4, but 4 plus 3 is 7, so that doesn't work. Or you could think, 1 times 4 is 4, but 4 times 4 is not 9, so I can't really use recursive reasoning to figure out the rule. I can't really base the next term on a previous term. Instead, I want to look at the position that each term is in and see if I can figure out a pattern to figure out the value of the term based on its position in the sequence. So I made a table again, and I filled in, okay, here's the first term, second term, third term, and I filled in the value of each term. And I'm asking myself, is there a relationship where I can determine the value of the term based on its position? So you might say, it looks like 1 squared gives me 1, 2 squared gives me 4, 3 squared gives me 9, 4 squared gives me 16. It looks like the position is actually helping me to figure out the value of the number of that term. So a deductive rule is when you are linking the value of the term to where its position is in the sequence. Okay? And to write that deductive rule using math language, I would say the value of the term is equal to its position squared. So the value of the second term is equal to 2 squared. Oops, let me go back. 2 squared. Or the value of the third term is equal to 3 squared. Or the value of the fourth term is equal to 4 squared. And that type of relationship is called a deductive rule. So, we've gone over 2 ways of writing rules for sequences. Recursive rule is where you are trying to base a new value off of an old value. And a deductive rule is where you're trying to figure out the value of the term based on its position in the sequence. Now on exams, you might see different vocabulary words. If you see term-to-term rule, recurrence relation, or inductive rule, that means the same thing as recursive. You might see position-to-term rule, nth term rule, and formula, and that is the same thing as deductive rule. I also wanted to just make a brief mention that while the letter U and N is a conventional symbol for a sequence, there is nothing special about the letters used. We could also call a sequence using the letters T and W, or I think in your Glencoe books they use A and N. It doesn't actually matter what letters you use, but the very important thing is that the subscript tells us where the term is in the sequence. So the letter N tells us where we are in the sequence, and the letter together with the subscript represents the value of that term. We are now going to go through some worked examples, and I'd like you again to copy these in your notes. I'm going to put the 2 example questions up first and let you copy them down. And again, you might want to pause them because I won't show them, for too long. Copy them down, and then I'm going to switch over and show you on paper how I would do the problems out. Okay, so example number 1. And example number 2. The big main concept is that we have learned by watching this video how to describe sequences mathematically. What's next? So tomorrow in class there will be a problem set distributed. We're going to work on the problems together, and then you're going to finish it for homework. I will be collecting and grading the assignment, the problem set, and it'll be graded from levels 1 to 7, and I'll describe that in more detail tomorrow. Thank you for watching.